Hello, everyone. Thanks very much for joining. This is Nizam. I've been with Sparx Systems for a few years now. And in this session, we'll be walking you through a couple of challenges that we encountered in complex deployments, especially Sparx platform deployments. And just want to confirm if my screen is visible, Sindhu.
Yes, Nizam.
Okay. So this session is a slightly advanced session. So I'm not going to be walking through the introduction or basics of what are the cloud platforms that we offer, what are the different variations, how we can support in lifting and shifting an existing EA setup from on-premises to cloud, or how we can actually tailor a custom solution for your existing cloud deployments. So there are various solutions and services that we can talk about, but there are already sessions where we have explained those in detail. I have shared these links in the chat window as well if you want to quickly refer to them now or later. But in this session, which is expected to be a fairly in-depth or reflecting on actual client scenarios that we saw, we'll be taking some liberty to assume that there is some awareness about the cloud offerings and how to even get started with cloud offerings. So if you haven't seen any of this already, I would urge you to take a look at these sessions that I have shared URL in the chat. So jumping straight to the actual crux of this session, I'm going to demonstrate with examples 5 interesting deployment scenarios that we have come across in the last 3 to 4 years of continuously working with Sparx EA customers who have either started with a full cloud deployment or they had existing legacy setup that has been in operation for a decade or so with a lot of I wouldn't say technical debt, but like huge repositories with a lot of branches and variations that they have accumulated over a period of time, and how we help them migrate and streamline their deployment so that they get the best out of whatever they have paid for. So to start with, we'll be looking at one of the most common scenarios that we come across, which is how do we operate in highly secure environments, which is pretty much every single cloud deployment that we come across. But still, there are particularly some instances where the level of scrutiny or the kind of contingency that is required is so high, the barriers or the expectations are so high, and we need to come up with innovative custom solutions to address those scenarios. So in terms of highly secure cloud environments, as I said, every single deployment that we do is kind of making sure that it's at most safe and secure, it's compliant to the ISO standards and SOC 2 and whatnot. But still, there are specific requirements that we have seen time to time. And that's what we are going to look at with one example here. It's usually around having a private network, limited access to anything that is outside the private network, being unable to give access to anything that is dynamic. So there's various cases that we see on a day-to-day basis. In this particular example, which is around a retail bank in the UK, this is very common when it comes to financial institutions or government and semi-government organizations and telcos where the level of compliance and security is the bar for security is really high. And this is an actual email. So I wanted to show from a actual request perspective, not just saying this is what happened. So in this email, there were specific pointers to say the SaaS instances. So we are now provisioning the entire enterprise architect application through browser. So there is absolutely no need to install anything in the user's machine. But the requirement here was none of the SaaS URLs should be accessible through public internet, should be only through their on-prem machines, within their on-prem systems, and that too should be done only through Direct Connect. But they still wanted to have access to the APIs, like the REST APIs, so that they could do a lot of integrations. But that also should be extremely secluded from the public network, so it should go through private links. And then there should be a regular data backup, and the data backup should also be sent to their internal storage, which is also apparently AWS, but through a private link and a VPC endpoint. So they were very specific about what they wanted, and we were able to. I mean, it's quite understandable, because at the end of the day, their security goals are also to achieve maximum security. Again, reiterating that every single instance that we do take security at utmost priority, but still these specific requirements would involve additional designs and additional provisioning. So at the end of the day, the goal is to have maximum security, reduce attack surface, and be ready for compliance. So compliance plays a key role in these requirements as well. And in this particular example, they were very particular that it cannot be accessed in a public internet. So it should be within a private hosted zone. And to factor to each of these requirements, we came up with a solution that kind of helps us meet those expectations, which included setting up the whole environment in a private subnet, which is what we do for every instance, but then we make it available through a public gateway. But in this case, we made it within a private subnet, and then we established private link connections between the customer's AWS account and our environment through the AWS backbone network. And we configured specific VPC endpoints and IAM policies to have the metadata exchange to their S3 bucket, or to be able to access the APIs through a specific a load balancers as well. So this solution helped us solve each of those requests that were specifically highlighted. And the way we do it is we take those requirements, we tailor, if needed, our usual deployment to meet those requirements, have an internal approval with their architecture or InfoSec team, which is all part of the enterprise deployment, but we make sure it's all documented, well articulated to them. We get a nod from their InfoSec team, and then finally go out and deploy, which eventually meets all those requirements that they have come up with. There are numerous scenarios that we can keep talking about in this complex environments, but this one particularly we want to highlight because this was A, very recent, and this was B, very specific in terms of what they wanted. Now, moving on to the next problem that we often see is when we try to migrate an existing on-premise deployment to cloud. It could be an on-premise deployment, or they may have it in their own private cloud. But what we usually see is not always, but in many cases, when there are large teams, the databases would have grown exponentially. And that could be due to audit trials, like baselines being stored in the repository, excessive usage of image assets and whatnot. But to be able to migrate those repositories to the managed cloud setup without losing anything and also without any data outage has always been an interesting challenge to address. So just the gist of it, the volume of the repository grows exponentially, mainly due to these three: audit trials, baselines, and image assets. There's been instances where with the customer's approval, we have taken a backup of audit trials and have just cleared audit trials. That would have reduced the size of the repository by up to 90%. That was like, there are instances where it was a big difference between before with audit trials and without audit trials. There's been multiple steps we have done to address this. But when the user insists that everything should be there and there's no room for any sorts of cleanup, because we can even clean up the baseline. So baselines is essentially an XML dump within the repository, and the larger the repository and the more XML dumps it goes, it's more like a cycle. So it kind of bloats your repository exponentially. So we could do a fair bit of cleanup before migration as well. But in instances where the users insist that everything should be as is, we still have managed to do that successfully. There are different solutions that we have adopted. This is an actual scenario where is a large telco. So this is it's a large logistics company, which we helped migrate from their existing Azure environment to an AWS environment. And to their surprise, when the repository was set up, it was just around 2 gig, but it has increased to more than 26 gig as in a few years, like nearly 3 years. And as I said, this is mostly due to the audits and baselines. We were not allowed to go into this repository and do any sorts of cleanup, but we assume that's what the reason was. But then there were close to about 800 plus modelers working on this repository every day. So it's almost like a business critical application. And the requirement was to have absolutely minimal downtime, and there was like zero tolerance for data loss. And there was a mandate to have the comms sent on a regular interval in the scheduled downtime. So we were given very stringent guidelines on how to operate, but the database was close to about 26 gig. As we would have expected, like initially we tried to do the EA project transfer, the utility within Enterprise Architect to do the project transfer. It's quite effective when the repository size is in the normal range, but anything like this was taking like unusually long time. Like the conversion was going for more than 40 hours nonstop. And if there was even a slightest interruption, it was stopping. And then there were multiple attempts that were required to even do this. So in any of these instances, we first do a non-prod migration, a test environment where the migration is done. The users are invited to test it, make sure they're comfortable with it before we do a production run. So when we were trying to do this, there were like multiple attempts required, and there was always data integrity issues in the migrated repository. So when we figured out like this is not really the solution that would ideally work in such scenarios, we started kind of researching on the best tools that are available. So we kind of were able to get our hands on the cloud basics from AWS to do the data migration, and that was remarkably faster. And to do that, we also have to establish a proper connection prior. So we have to do the secure whitelisting between Azure and AWS, and to make sure that the post-migration data is the data integrity checks in EA has to be run on a regular basis after migration to make sure there's no data loss as well. And we have done this in multiple instances. There's been instances where we did it from Azure to our cloud environment, which is mostly AWS, or there's been instances where it's been on-premise to AWS or another AWS instance to an AWS instance, in which case we have used the AWS's DMS migration. But these different tools, once we started using them and defined a set of automated ways to make sure the data integrity is correct and there is absolutely no data loss. We have like a set of automation that we have built to make sure there's no data loss. We were able to get these migrations done quite seamlessly. And this was just a testimonial to say, after all that stringent constraints that were given to us in the migration, the users did a thorough testing of it, and they were quite happy to go ahead and decommission the old Azure setup in a few days. So this is a successful result, but to get to here, we had to do a number of attempts, do a fair bit of R&D to arrive at the right tools to get it done. So just moving on to the third challenge that we have faced quite I wouldn't say quite normally in almost every instance is to have a proper federated SSO set up in the cloud hosted environment. In most cases, it will be fairly straightforward, but there are instances where there's going to be more challenges to address. In the first place, why is SSO so important? I'm sure everyone in this call is quite aware of this, but the more cloud adoption we see, the need for an enterprise SSO has become very prominent. Like a proper federated single sign-on identity management with two-factor authentication is almost a mandatory thing in the InfoSec policies, mainly to manage the joiner leaver process. So if the tools are managing users within their own user management system, it almost becomes quite hard to manage the joiner leaver process. So almost every InfoSec team is mandating a federated SSO. So this is a step that is mandatory in every deployment, I would say. But the challenges that we see when we try to do this is, if you start from the most basic challenge, it is the legacy role-based access control that would have been already configured in the EA repository. There will be users and user groups that would have been created in Enterprise Architect repository, and that's quite well defined, but it has been built over years. The user's username is not necessarily an email. The user groups and users are managed locally within the tool, and our task would always be to migrate their existing role-based access control and tie it to a federated system, matching the groups, migrating every user to the right groups. All those were the initial challenges that we need to address, but through our R&D, we have more streamlined ways of doing it. So that's one of the basic problems that we come up with. But in this particular scenario, what we will be highlighting is a particular client where we set up a SaaS platform. We're not able to get our SaaS instances authenticated, primarily due to the restricted or managed devices, which wouldn't accept an external SaaS instance as an accepted system. There are other challenges as well. So there will be multiple departments with mixed SSO setups, in which case we need to somehow consolidate them. Or there's also all this operational and change management processes that is required in the way people are onboarded. So there are usual challenges, but in this particular case, we are going to discuss a large financial services organization where they use an Azure Entra ID for SSO. They moved to a SaaS platform, but we were not able to get them to authenticate using their SSO system. It's primarily because the organizational policy wouldn't allow anything that is external to be authenticated. So the EA SaaS platform as a device cannot be joined into their tenant as a compliant device. So it was almost ruling out these dynamic instances. So it's pretty much a streaming service that we use for rendering EA on a browser, which boils down to be identified as a separate device. And when the SSO wouldn't allow authenticating something like that, there was a challenge. But then what we realized was there's only two ways to do it. One is there should be a static or a specific IP address which should be pre-authenticated, and then we should have some mechanism to use that static IP to authenticate all our dynamic EA SaaS instances. So that was almost the only option that was left to us. This is an actual discussion with the end user. And to do that, we designed a system where we enabled a NAT gateway with a single static IP, and we managed to work with their InfoSec team to whitelist that particular static IP within their Azure Access Policy. And that enabled our EA SaaS instances. So we introduced the logic to use this and dynamically authenticate all our instances. But this took us a fair bit of effort to also come up with a solution and make it work. But at the end of the day, what we did was this: as a NAT gateway for the SaaS environment, get it authentic, whitelisted in the end user's access policy, and then that kind of allowed traffic in compliance with their organizational protocols. And after we implemented this, we retested it, and the user was able to confirm that the solution solved the problem. So this was one interesting scenario that happened in recent times, which I wanted to highlight. But this is not the only one. As I said, SSO is almost mandatory in every deployment, and we've been continuously doing a lot of R&D to make sure we support every possible combination, be it Ping or Okta or any other ADFS solution. And what we do is, most of these deployments becomes a challenge when there is an existing practice, and that practice has been going on for a very long time. And this was one of those instances where we migrated from an existing EA on-premise setup, and we were using they were using Okta. So we migrated, we tested, and we validated. And this was in the process of migration, so they couldn't even enable it in the long term, but we need to verify it. So this was one instance where we verified using Okta. And this is an even more interesting scenario where this whole process was almost 6 weeks long because of the challenges in getting all the team from the user side on board to do it. So you could see the mailing list going like 4-5 lines, but that's how big the team was who was kind of involved in doing this migration, getting the users from the legacy or role-based access control converted into the new system, a group admin in each of those departments to be able to test the migrated or the non-prod system. So it was quite a tedious process to get such a setup converted, but we've been continuously doing a lot of R&D to address those, automate it, and make it simple. And it's more often than not, almost pretty much every day, there'll be a new challenge. So this is another cloud setup, but where there is an issue. So they have tried to do the SSO themselves, but at the end of the day, they were not able to make it work. But then, because we have the knowledge or IP, the experience doing it, we were able to point them to the right direction, and that the small hint would solve major hurdles. And this was another example of those. So setting up an SSO, though it sounds quite straightforward, this is one of the most important steps that we see. We will have continuous interesting problems from the user side. We have fine-tuned our process to make sure this is done smoothly, but still this requires the end users teams to be involved. So we need to give them enough notice, engage the right people. So a cloud deployment, this is the major or a critical step to to address before it goes live. So it's been always an interesting task to implement the federated SSO. Now, just moving on to the next topic, which is distributed teams. Whilst 80-90% of the teams are in one geographical locations, the large enterprises whom we have worked with, it's very common to have teams across continents. I mean, there's across states is common, but there's mostly teams across continents, and most of them would have had a fair bit of challenge when there was an on-premise setup. When you have a thick client and you're trying to access repositories in a different geographical location, it kind of makes it quite interesting. So our success has been in enabling performance, like high performance for distributed teams. And this could be teams who are in multiple regions or multiple continents accessing EA repositories. And it's very often needed because the experience should be consistent for all users. And the latency, I wouldn't say can be completely eliminated, but we can reduce the latency significantly using some of these deployment practices so that they get optimal performance. I wouldn't say like the best performance from every region, because at the end of the day, when it is in one region, they would get the best experience. But then what we want to do is to optimize for people who are connecting from a different region to have acceptable or like really good experience as well. The challenges would surface when there is network latency, like when there's firewalls and there's rules in corporate environment which has to be addressed to access an external network. So there's been quite often a problem for us, and these surfaces very often when they do a export or a diagram generation or a version baseline or a merge, these are the kind of tasks where it fails. And when it fails due to timeouts, it becomes quite a challenge for us, because an XML, so when you're trying to import an XML file, or when you're trying to merge from a baseline, essentially what enterprise architect is doing is merge an XML file to your repository. And the process is quite interesting because it deletes the existing content and then tries to update it with the new content. And if there's an interruption in this process, there's a high risk of losing some data as well. So we have to make sure we take backups in regular interval, especially before a large import to do it. But these large task failures is quite a challenge when we have geographically distributed teams. And then when you have frequent disconnections or synchronization delays where due to internet issues, it becomes even more spelt. It kind of makes the whole essence of a shared repository questionable. I've seen many teams have moved back to file-based repositories because of these latency issues in the past. So, I mean, there are teams which, I mean, I won't be able to mention the exact names, but they went from a shared repository to individual QEAX files, and they were using, some common folder where people dump their XMLs, people were importing from it. All these were because of the latency issues. So it kind of has a huge impact on the essence, essentially collaborating between multiple teams on a common repository. When we do a deployment on these kind of scenarios where teams are distributed across regions, we make sure it is done with utmost attention to have availability zones in multiple regions. So this is a standard architecture, deployment architecture for a multi-zone deployment, where, as you can see, almost everything that we deploy always goes within a private subnet, and it's just made available through an ACL at the end of the day. But what we have is a private, there is a actual primary database and application server, and there's also a standby application server and database, and we try to optimize this depending on how distributed the teams are. So there are occasions where we have set up EA SaaS instances in multiple regions and have connected them to the EA repository through the AWS backbone internet, which is much more reliable than having to access it through normal internet. So we have done instant deployments with EA instances locally in that own region, but the repository is in one region, which could be North America or Europe. We have tried in the past to have replicas of repositories, but with EA's architecture, it has always been a bit of a challenge to get that working. But we have addressed it in different ways to enable performance, especially using EA SaaS streaming. So if we are still have to work with thick client EA instances, we have found it. That hasn't. Even if we have EA repositories on cloud, if you're going to access it from an installed application, the latency is still spelt. But with the SaaS deployment, we have seen the performance optimization quite evident, and these are some of the examples. So we have had people reporting to us that they have tried to transfer a local project to a shared repository and it fails due to timeout issues or delays. These are basic steps that one should be able to do, but because of the way the repository is set up between like different regions or different geographical locations, it makes it quite difficult. But when we had the SaaS instance deployed for them, and with the best practices that I just mentioned, they were able to clearly see a big difference in performance, and they were immediately pushing for having such instances, at least a few of them, to do the migration to start with, whilst he is going to have a conversation to get that as a standard practice across. So the architecture that we are employing here is to address real problems that we see on a day-to-day basis. So this is another example where the user comes and kind of say, there's been a significant delay when they try to connect to their repositories. But once we have a solution that conforms to that such a distributed deployment, they were able to see some clear results. XMI export import is a most common complaint that we always see, because that's inevitable when you want to take a branch, or you want to take a backup, or you want to merge someone else's work into your repository. You need to do XML export import, and if that's done through a connection that is slow with a lot of latency, that's almost a recipe for trouble. So we have seen people quite positive when they start using the cloud hosted deployments, especially focused on addressing these issues. So we have just seen 4 different scenarios. The first one, we started with having addressing the challenges in highly secure environments. So every single deployment that we do would usually involve a thorough discussion with the InfoSec team, going through all the compliance checklist, completing the CAIQ questionnaires and whatnot. We are ISO 27001, SOC 2 compliant. So we need to have a proper dialogue with the InfoSec team even before making a case for the cloud instances. And we have been quite successfully doing it. So all the challenges that arises in a highly secure environments is something that we have seen and addressed. And then we looked at how the large EA repositories, migrating them to a cloud environment, there are different ways, like cleaning it up, trimming it down, or using some of the advanced tools to migrate. And then we looked at how the SSO implementation, although it sounds quite straightforward, has its own set of challenges and complexities. And we have worked on at least 200 different deployments now, making our team quite experienced to address such different scenarios. But we have been always focusing on continuous R&D to come up with the latest ways or the innovative ways to address those challenges as well. And then we also looked at setting up a high performance deployment for distributed teams, which is very common in large enterprises. But nevertheless, that is also applicable even if your teams are distributed across different states or within like different countries within Europe. You can still achieve performance optimization by doing proper setup for distributed teams. And the last last scenario that I want to highlight is to have advanced disaster recovery, kind of included in the setup. This is an interesting example that I want to show, but we make sure the environments are configured to support disaster recovery in any cases. So it could, depending on what the end user expects, it could be multi-zone disaster recovery, or it could be multi-region disaster recovery. Why I'm emphasizing these two scenarios is because we would have, when we initially thought we would go with multiple geographical locations for the disaster recovery, but then the data residency clause in the security questionnaire would specifically mention that the data should not reside anywhere outside that country or that particular continent. That would mean we can only go with multi-regional setup so that the disaster recovery will work within, if it is within the same region. But if there's a outage in the entire region, it may have a challenge. So we have solutions for different scenarios. So in this case, all our setup emphasizes on backups and 24/7 monitoring. So it's not that we do it only for the instances where specific DR expectations are set. Of course, when the DR expectations goes higher, we do more advanced measures to address it. But all our setups has regular database and application backups, and that's done twice a day and retained up to 14 days. And that will help us to have a maximum recovery point objective within 12 hours. So we do twice a day, retain it for 14 days, and each one of these are configurable. There are users who said the backup should be stored for a very long, extended period of time. There are users who have requested for backups in a more frequent basis. All these are configurable, but every single standard deployment of ours takes all this into consideration, and we have a real-time monitoring using AWS Cloud Watch and Site 24/7 applications set up in all our instances to make sure any outage or anything that could fall apart is immediately addressed and the instance is up and running. But now coming to the disaster recovery part. So all those are standard operations. But coming to disaster recovery part, it's very important, depending on how critical the architecture practice is, it's really important to have proper DR set up to ensure high availability and to ensure business continuity and minimum downtime during cross-region failovers or failovers. There was a recent outage that we all know with AWS as well, and we saw in the 2-3 instances where cross-regional DRs was enabled, whatever should have happened automatically. So the lookup happened automatically from an alternate region, and there was almost no outage in the environments where we had such setup. Not everyone goes for extended DR setup, but that's something that we can enable. And as I said, we do our setup across zones when people have issues with data residency, or ideally it should be done across regions, or like, countries, like different geographical locations. I mean, especially continents. I mean, if possible, there are some clients who wanted this way and some people who just wanted a different zone. We have solution for both, but this is an interesting example that I want to highlight. This is of a leading automobile manufacturer in Europe, and this was exactly when there was some tensions around Europe due to the war a couple of years back, and the request from the client was that we simulate a disaster recovery scenario by triggering a false alarm. So they came up with this request. We did inform them that it's going to be an extra effort and it's going to have its own downtime implications and cost associated with it. But it was an organizational policy that they have to adhere to make sure all their applications are safe if something untowards happen. So the request was to simulate an actual DR in their actual environment, with a false alarm. And what they had was a multi-AZ, a multiple availability zone setup of their entire EA Prolaborate suite, which almost guarantees 99.5% availability as per AWS standards itself. But we were given some recovery objectives. So the recovery point objective was it should be within 12 hours. And the recovery time objective that the user gave us was 24 hours, before which they wanted their entire application set up, all their users, user configuration, repositories, everything pretty much back to normal. Even after simulating a DR scenario. So what we did as a DR simulation step was we actually raised a false alarm. We informed all their stakeholders well ahead of the test. We were also informing them every 30 minutes of the downtime. But then the data restoration from the alternate zone was initiated automatically based on our DR. This whole process was required. I mean, they wanted us to record the whole process and give it as a documentary evidence to their team. So we recorded pretty much the whole process for them. And then finally, when everything was back and up and running, we verified the configuration, service status, and ensured full service restoration happened. And the actual outcome was way better than what was given to us as an expectation. So the full environment was restored and operational within 90 minutes. That was well within their RTO. And we provided a 30-minute interval updates to all stakeholders throughout the process. And we also were able to deliver a comprehensive root cause analysis report at the end of the exercise, confirming all SLAs were met. So this was a very interesting exercise because it is almost like an insurance policy. We don't know how it works until we really want it, and we want it only when something untowards happen. But in this case, the client wanted to simulate it in an actual environment, and when we did it, it was, I mean, I shouldn't say it's a learning, but it was quite an experience because we were able to see really positive outcomes, even better than what they set as a recovery objective for us. So in summary, these were 5 different deployment scenarios that I wanted to highlight. I mean, I have done a number of presentations on the cloud platforms, how it works, what are the different options that are available, and I'll be more than happy to have a call or a discussion with anyone who is interested to explore those options. But in this session, we want to dive into the specifics. I know I skipped a lot of basics. It could have been a bit vague to someone who is new. My apologies for it, but I wanted to make this a bit technical, a little pointed to the actual problems, so that if something like this is happening, or you kind of encounter some of those, there are solutions that are already defined for it. So we went through these 5 different scenarios, which is very common. There are more. I mean, I had to trim my slide by a significant number to ensure it's not boring. It's already 45 minutes, but it's also within time. But if anyone is interested to have a detailed discussion, I'll be more than happy to connect and discuss. I'll just quickly see about questions, if there are any. Okay, Sindhu, are there any questions?
Yes, Nizam, we have received a question from Patel. How does the features related to DBMs and cloud providers migrating capabilities provided? For example, we used Azure's capabilities to migrate 2D data from on-premise to Azure. It's in chat box.
Yeah, that's fine. So, we are using some of those tools as well. What we just do is we make sure post that migration, we run some of the EA scripts to validate that everything is come across. The data integrity checks are run and make sure that everything is in working condition for Spark. So yes, you're right. Using some of those tools, I even mentioned the name of those tools, but we just make sure that's tested and validated within EA's perspective to make sure it's there's no data loss. So even in that particular example, I think I did not mention, but even after all the integrity issues being checked and addressed, users would come back to say, hey, I'm trying to execute this particular script, but this script stops somewhere. So there could be minor issues. So we have addressed a lot of those anomalies that arises after migration through extensive automation or validation from an EA's perspective. That's all we have done on top of it.
Thank you, Nizam. We have another question from Sudipta. So the on-premise tool is causing a lot of latency and server crashes. I had to do a lot of workarounds. No concentrate support has been provided. So far, are those covered fully in the SaaS platform?
Yeah, absolutely. See, one of the things with the setup at times with on-premises is the performance. I think that's sort of what we mentioned. So we try to address those issues to a great extent in the cloud setup. I mean, there could be there are multiple things in it. So even an on-premise setup, we have ways we can assist with an on-premise setup as well. So we call it assisted deployment to make sure it's done in the most optimal way. But when you look at cloud deployments, it's definitely intended to address those performance issues. I would like to thank you all for joining this call. This session, as I already mentioned, this went into the technical details pretty much straight away. But if you want to have a look at the introductory videos, I've shared the links to the introductory videos on what the cloud platform is and how we can assist in migrating your existing repository. I mean, Sindhu, if you could share those links once again, that'll be great. But if you have any questions that you want to discuss in detail, you can always reach us in using these emails, sas@sparxsystems.com or visit sas.sparxsystems.com.